Metals and non-metals. Learning about occurrence of metals. Occurrence of metals. The Earth's crust is the major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. The elements or compounds which occur naturally in the Earth's crust are known as minerals. At some places, minerals contain a very high percentage of a particular metal, and the metal can be profitably extracted from it. These minerals are called ores. Extraction of metals. Having the knowledge about the reactivity series of metals, we can easily understand how a metal is extracted from its ore. Some metals are found in the Earth's crust in the free state. Some are found in form of their compounds. Gold, silver, platinum, and copper are found in the free state, as these metals are the least reactive. Copper and silver are also found in the combined state as their sulfide or oxide ores. The metals K, Na, Ca, Mg, and Al are so reactive that they are never found in the nature as free elements. The metals zinc, iron, lead, etc. are moderately reactive. They are found in the Earth's crust mainly as oxides, sulfides, or carbonates. You will find that the ores of many metals are oxides. This is because oxygen is a very reactive element and is very abundant on the Earth. Thus, on the basis of reactivity, we can group the metals into following three categories. 1. Metals of low reactivity. 2. Metals of medium reactivity. 3. Metals of high reactivity. Different techniques are to be used for obtaining the metals falling in each category. Several steps are involved in the extraction of pure metals from their ores. A summary of these steps is given in the figure. Each step is explained in detail in the following sections. Enrichment of ores. Ores mined from Earth are usually contaminated with large amount of impurities such as soil, sand, etc., called gangue. The impurities must be removed from the ore prior to the extraction of the metal. The process using for removing the gangue from the ore is based on the differences between the physical or chemical properties of the gangue and the ore. Different separation techniques are accordingly employed. Extracting metals. Metals are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar, HGS, is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide, HgO. Mercuric oxide is then reduced to mercury on further heating. Similarly, copper, which is found as Cu2S in nature, can be obtained from its ore by just heating it in the air. Extracting metals. The metals such as iron, zinc, lead, aluminium, etc. are moderately reactive. These are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to the reduction, the metal sulfides and carbonates must be converted into metal oxides. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. The chemical reaction that takes place during roasting and calcination of zinc ores can be shown as follows. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it is reduced to metallic zinc. ZnO plus C gives Zn plus CO. Besides using carbon, coke to reduce metal oxides to metals, sometimes displacement reaction can also be used. The highly reactive metals such as sodium, calcium, aluminium, etc. are used as reducing agents because they can displace metals of lower reactivity from their compounds. For example, when manganese dioxide is heated with aluminium powder, the following reaction takes place. Thrice MnO2 plus 4Al gives thrice Mn plus twice Al2O3 plus heat. Electrolytic refining. Many metals such as copper, zinc, tin, nickel, silver, gold, etc. are refined electrolytically. In this process, the impure metal is made the anode and a thin strip of pure metal is made the cathode. A solution of metal salt is used as an electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. Summary: the Earth's crust is the major source of metals. The elements or compounds which occur naturally in the Earth's crust are known as minerals. We can group the metals into the following three categories. 1. Metals of low reactivity. 2. Metals of medium reactivity. 3. Metals of high reactivity. Ores mined from the earth are usually contaminated with large amounts of impurities such as soil, sand, etc. called gangue. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. That is all in this topic, students. Let us learn about corrosion in our next topic. Keep learning!